بسم الله الرحمن الرحيم.
Hello everyone. Today I want to teach you the idea of supermesh. What is a supermesh? Before we get to the idea of supermesh, you probably have been learned the idea of supernode, or how the nodal analysis work. In nodal analysis, we have 3 nodes, and by about 2 or 3 nodes, we try to find out the currents that going in, or not the currents, the voltage going in by doing a KCL. That's a node analysis. And then supernode is if between 2 nodes there's a voltage source, how are you going to find it? For meshing, we're going to find current. We have 2 loops, and we already did a problem before in a video. You can check it out on my channel. For supermesh is when you have a current source between your 2 mesh loops. Now, why is this a problem? Just in supernodes, when you have a voltage source, because you don't know where's the voltage drop between those 2 nodes, the same situation happens in a mesh. If you have a current source, you don't know how much voltage you're going to have because the current stays the same. Because that current source makes you a problem, and typically if you start doing it, you're going to get a situation when you have to do the current source in your mesh analysis, so you have to go for a super mesh. For example, we have a 2 amps current source in this problem. What do you do for the super mesh? When you do because in supernode, we're going to create a boundary around it, and then we're just going to do a KCL at the supernode. For a mesh analysis, you're going to assume that that branch doesn't even exist there. That's what you're going to assume. And you're going to create 2 different loops with boundary and stuff to solve your analysis. Now what you're going to do, you're going to do a KVL at supermesh instead. I'm going to use a reference node here just for fun. I'm going to go up. I'm going from minus part, or the negative part of my voltage source, to the positive part of my voltage source. So it's positive 5 volts. Then I go to the first resistance, and I am inside my I1 situation. And I'm going to also say the clockwise rotation is positive. I have to do this in the beginning though. Remember that. Which I forgot. And then I have 2 ohms and times I1. Basically in the same direction I have my current, so it's positive and it's going forward. Then I'm getting inside that 1 ohm resistor. This is the reason why, even though my resistance are in the series, I'm not gonna connect them, because I'm in a super mesh idea. I'm not supposed to connect them, because when you have the 1 ohm resistor, you're multiplying that by I2, because now you're in I2 region. You're going to create the I1 region and I2 region. You're going to assume the first voltage source that we have and the first resistance of 2 ohms, because they're in the first loop that we had as I1. But once we get into that 1 ohm area, we're going to assume I2, because we're in I2 area. So plus 1 times I2, and then minus 4 voltage, because I'm coming here, I'm going from positive to negative and a voltage source. Looks like I am losing altitude, so it's minus 4 volts. Then you're just gonna do algebra and get 2I1 plus I2 equals minus 1. This is a bit problematic too right now, because we only have 1 equations and how many unknowns? 2. So we have to do another equation that will probably give us something, right? So let's go ahead and do that. After finishing the KVL that we had, or the Kirchhoff's voltage law, at our supermesh, now we're going to switch and do a KCL at our supermesh, or Kirchhoff's current law at our supermesh. And we know there's a 2 amp source there, right? So our I1 and I2 should probably equal to that. Or maybe not, you'll see. We're going to assume that anything that goes, and this is not a really good direction, I'm going to solve that. Anything that goes into the node, again, a circle is the node that we probably want to choose, and we're going to do our arrow going into that circle and say any currents going into the node is positive. For our Kirchhoff's current law, or the KCL that we want to do. So we're going to do a schematic. We know that I1 is going into that node because we're doing clockwise, right? 2 amps is going into that node because we know the direction is going up, and I2 is going out of it because I2 is doing a clockwise on its own boundary, so it's going down. So we're going to do a KCL like this. We're going to have I1 because it's going into the node, so it's positive, plus 2 amps going into the node is positive, and then minus I2 because I2 is going out of the node. It's going away from the node, so it's minus. So that's going to give us I1 minus I2 equals to negative 2 amps because that 2 is going way down. So we're going to find a second equation that relates our I1 and I2 just like the previous question that we had. Now it's time to put them on a matrices and just finish the problem. So I'm just going to put it in. We had 2 and 1 in first equation times I1 and I2. So 2 and 1 represent our I1. And the negative 1 was our answer, and it had I2, which we had 1 for it over there. And they had 1 and negative 1 in the second equation that we had, I1 and I2, and then we had negative 2. So based on that, we just solved the answer. But again, if you really wanted to solve this, it's fine. You can just put this in MATLAB or just solve it like the last question. I'm not going to solve it. If you want to do it as a practice, go and solve it.